Good morning, everyone. This is our second kick session today and final one today, actually. And we've got James and Will here to talk about the testing assistance tool, Galasa. Both experienced presenters. So if anyone's got any questions, it's normal rules apply. If you pop it in the chat, Nick or I will have a look at it and hopefully pause the presenters to answer the questions. And there'll be a Q&A at the end. So if you want to save any up to the end, please feel free. But without further ado, James and Will, please take it away.
Thank you, Rob, for that introduction. So welcome to the session, Galasa Half Full. As part from being a fairly appalling pun and play on words, it's also a session talking about bringing back some of the optimism to integration testing, bringing some of the sparkle, some of the enjoyment out of it. If you've never heard me speak before, you're incredibly fortunate. Some people have been forced to listen to me for years. But don't worry, it's not me for the entire hour. Rob, please don't just nod your head. You meant to, say, no, we love having you here, but
I was on mute. That's not my head.
Oh, okay, fair enough. But you're not having to listen to me for the entire hour. I've also got James Davis with me, who is one of the Galasa engineers and doing an absolute ton of work around our DevOps pipeline for Galasa, and also how we use Galasa to test some different aspects of the Kix runtime. So if we're going to be talking about bringing back the optimism to integration testing, we have to say, well, why isn't there optimism there already? And that's basically because automating integration tests is hard. It's very hard. Doing it manually is hard enough. But thinking about how to turn that set of manual tests into a set of automation that can be run reliably, that can be run robustly, and it kind of at scale can be really quite tough. Now, automating integration tests is something that I've spent the best part of my career doing. I'm a tester, that's all I've really known, and developing frameworks to allow testers to do their jobs has really become a thing that we're quite well known for within IBM. But if integrating testing is hard, why is it hard? Well, the first thing is you're going to need a whole range of different tools. Because we're talking about automating an integration test and not just a unit test where everything is stubbed or mocked or recorded and repeatable, I've now got to deal with a whole slew of different tools, maybe 3270 terminals. Maybe I've got to submit some batch jobs. Maybe I've got to interact with the Kix region and inquire on some resources. So there's a whole range of different tools that I need, and that's just for the ZOS side. Very few applications are just ZOS centric. They interact with some distributed software or maybe some on-prem or off-prem cloud software. And to do an integration test, I'm going to need to interact with those tools and technologies as well. Now, remember, that's just to run an integration test. To automate it, I need to find a way of automating all of those tools in a consistent manner to try and make my job as easy as possible. The tests I'm actually running may span multiple different platforms. So therefore, I've got things like code page conversion to consist with. I may have to deploy certain parts of my application or just bind to an existing deployed part of my application. And I've got to work out how to do that on the fly for each and every test run. Speaking of the test runs, I've got to manage all those test runs. Now, the default is to do that sequentially, one by one, run a test, wait for that test to run the next test. But that's slow. I need to run these things in parallel, but if I'm running them in parallel and they're touching ZOS, they may be touching shared resources, shared data, shared security. How do I handle the interaction of a parallel set of tests running against some shared resources, making sure that we don't get non-determinism within my tests? And then it's not just having the tests and automating them. I've got to integrate them with my CI/CD pipeline. So I can run them on demand as part of my CI pipeline to check that we've not broken anything by introducing new code. Is it any wonder that integration testers have a headache? Is it a wonder why integration testers wear loud shirts? It's our coping mechanism with the headaches that we have to deal with on a near daily basis. So let's have a look at a short example. Now, it's a presentation, so the application demo is fairly straightforward and easy to understand. And I know that in the real world, you will have much more complex applications than this. And the same tenets that we're going to discuss here apply to those more complex applications. But just so we can explain it within an hour and we're not here, I did go for an all-day session, but apparently Rob and Nick weren't interested in me talking for the entirety of the day. So here's my application. And basically, I've got a web front end or a mobile web front end that the user is going to interact with to do something. Let's say to transfer money between some different accounts. And that application is hosted by a web server that is hosted in the cloud. Now, this could be an on-prem cloud, it could be a public cloud, but we're basically talking some sort of containerized application. It could actually be sat on distributed hardware on-premise. It doesn't necessarily need to be in a container, but in our case, it is. And that container is going to serve up the web page or the web pages and the web application, but it's also going to act as a conduit calling on a set of web service or SOAP-based XML calls into a Kix application running on ZOS, and that's going to drive some COBOL, interact with the database to provide the data and the transactionality that the web application needs. So that's our application. So what do we need in order to test it? Remember, I'm not talking about unit testing. So I'm assuming that the unit testing of this has all been done. Okay, I'm talking about the end-to-end integration testing, going from the web browser by driving the user's interactions against that browser, simulating that set of content, and then driving that request into the web server, into the Kix application, and checking that all of the results have come back. So not just saying, did the web browser give me the right result, but did those interactions cause or flow the right set of updates to happen in my system of record? So in my my cloud-hosted web server, I've also got to consider, well, where am I putting that container? I know it's in a artifact repository. My CI/CD pipeline may have instantiated it. It may not have done. I may need to get it from my get it from my repository, artifact repository, and deploy it myself in order to run the test. My ZOS application, well, I've probably already got a Kix region that I can use for testing, and my CI/CD pipeline may have updated that Kix region, but how do I bind my test to the Kix region? So that's just one set of concerns, but I've got another set of concerns of, well, I've got a test here where, let's say my CI/CD pipeline has deployed the cloud-hosted web server. Okay, well, I need to bind to that, or I need to, if it hasn't provisioned it, I need to provision it as part of my test. My Kix application, I need to drive that and make sure that I'm the only one using that Kix application while this test is in flight. So no other test comes along in the automation and, you know, removes money from the account that I'm also trying to interact with. There may be some work that I do to drive those simulations at the web browser level and check them in the Kix application. But I also may want to drive some of the SOAP XML APIs myself as part of the test. I may want to interact with APIs that the cloud-hosted web server is also advertising and making available. There's lots of levels within this application where I may want to, you know, just pull at something, poke at something, prod at something, either as the entirety of a test or in order to force a situation for another test to happen. So there's lots of things that I need to consider. And the neat thing about the Galasa framework is that it allows me to interact with all of those different components. And it does this through a modularity point called a manager. So each manager is the subject matter expert at doing one thing and one thing only. So we have a ZOS batch manager that understands how to run batch jobs on a ZOS system, how to retrieve the output from a running ZOS batch job, and how to interact with that. Knows nothing about ZOS files, doesn't know what a container was, wouldn't know the difference between wouldn't know the difference between a container and a mobile phone, even if you asked it. But it does know about ZOS batch jobs. I also have a manager that knows about containers and can deploy a container into a Kubernetes namespace and bring it up, instantiate it, and allow me to interact with it. The Galasa framework combines this set of managers together to allow me to write a single test case that can span all of those integration points and allow me to access all of those integration points in a consistent manner. So as a tester, I don't need to worry about, well, which Kix region am I testing against? Is it locked for my use? Where's that queue that I need to access? All of those things are abstracted away by the Galasa framework, allowing me as the tester just to focus on, well, how do I test my application? Not how do I deal with all the other bits of integration logic that I need to worry about. We can move on, James. So we're going to stop now. And I promised that I would stop speaking at some point. And we're going to pass over to James. And what James is going to do is we're going to start by taking that application that we've just discussed and showing you the Galasa test case that allows me to integration test part of that application. So it's going to drive the web browser user simulation. It's going to drive APIs in the web server, and it's going to interact with the Kix application to ensure that the changes that we made at the browser percolated all the way through to the changes in the Kix application. Over to you, James.
Thank you very much. One direction. So hopefully you'll be able to see a Eclipse session in front of you here. Let's just make sure we can see it nice and big. Is the font big enough, Will? Can you read that quite clearly?
Yep, I can read that.
Sweet.
Even with my failing eyesight and glasses, I can.
So what I've done in this test case is I actually have minimized a lot of the code so we're not distracted by looking at how everything works. And I've left open some of the things that I want to discuss straight off the bat. And the first thing you'll actually notice in a Galasa test is there's usually a large collection of annotations at the top of the test class, which are the integration point for our tester to be able to talk to all these different resources, as Will was discussing. So this is my ZOS regions or my Kix application that I want to be talking to. This is my Selenium web drivers if I'm going to be instantiating some of them. This is the application managers so if I'm going to have some understanding of what I'm going to be testing, and any other test tools that we're going to be interacting with. And some of the things that I would just like to point out straight off the bat is if we have a look at something like the ZOS annotation at the top here, we can see it's actually been tagged with what we've called SymBank. And what this is doing at runtime when this test is being executed is it goes to the Galasa framework and says, I'm looking for an application, a ZOS region that has the SymBank application installed upon it. And then at runtime, this test is bound to a region that has the application installed. So I've not had to worry about endpoints, ports, how I'm going to be talking to whether this is TLS or not. I'm just being provisioned with an image to this test at runtime. This is particularly helpful if I have like lots of different tests, because they're all just, instead of talking to the same endpoint or the same region, they can be allocated resources as they're freed up so we don't hit those kind of collisions as Will was discussing. Scrolling down, this is a rather simplistic test class because this is a demonstration and we don't want to get too distracted. So we have three test cases here. One that's just going to ensure that my application is running as expected and it doesn't do anything particularly fancy. It actually just ensures that the object that is returned to the test called bank terminal retrieves a screen that contains the word SymBank main menu. We then have another test here, which is going to do some interaction with the Kix web service. That's that SOAP request that Will was talking about a second ago. And then the final test here is our big web app integration test. So this one is going to instantiate a Selenium web driver. It's going to drive a web browser. It's going to communicate with a provisioned containerized web server, which is then also going to be talking to our backend Kix web services. And the whole thing is going to be bound together and running nicely at runtime. So to put my money where my mouth is, I'm just going to run the test. And hopefully we should see on the log in a second as it comes flying past, is we should be seeing some 3270 screens. We've got some messages here saying it's starting up a Docker container. So this is that cloud-hosted web server. In this case, I didn't have a CI/CD pipeline that instantiated it for me. So the test has come along and said, right, there isn't one running. I'm going to go start one. We've actually got a Selenium engine, which has been starting in the background now, which is waiting for that web server to come up. That's up and it's happy. And now the test has started. We're driving some of our 3270 screens, which are checking the credited amounts of a generated and opened bank account and credited money to it. Hopefully we should see some red text pop on the screen in a second, which is the Selenium logs coming back to the test. This process does slow down a little bit when I'm sharing the screen, because unfortunately we're using the JVM runtime on my computer, which really does struggle with Zoom screen sharing for some reason. But hopefully that should come back to us in a second saying we've actually run our Selenium test. So this is in the background, you can't see it. This is headlessly running a Firefox browser inside of a Docker container, which I think is really quite cool. And it is driving that browser to make sure that we can make some changes to an account. We can then log on via a 3270 screen and validate that we made the changes to the system of record all the way back running in ZOS. And our test has passed, which is all great to see. There's a few more messages coming in because it's cleaning up everything. This is one of those important aspects for a test, is not only can we bring stuff up and make environments that we need for the test, but we also understand how to clean them up. So that was the console output, which is all very nice if I'm running this locally on my laptop like I am. And I could have even added breakpoints to this test, and we could have stepped through different components and actually explored what Galasa was doing at different levels. But one of our big features is we like to be able to run in isolated environments as part of a CI/CD pipeline. So what happens if that test had come back and it hadn't passed, and it in fact actually failed, maybe at 3 in the morning, especially when I wasn't awake watching the console output? In that case, we're going to want to be able to view everything that happened in that test. So I'm just going to refresh this view because I haven't refreshed it since yesterday. And U10 was the test that we just ran. I can get a very simplistic breakdown showing that this test has passed and all 3 different methods have passed. And I actually have access to the complete run log, which we just saw spewed out on the console, which is all very nice. One of the more impressive features, however, is actually this shared stored artifacts view, though, because this provides us a single location to go and collect all of the resources that the test was interacting with. So I mentioned the fact that one of the very early tests was just submitting a SOAP request to our Kix web service. And here I can see both the request and the response object that that test was using as part of it. And more than that, I don't have to now go log on to the 3270, I don't have to go log on to the ZOS LPAR that my batch jobs were submitted to go retrieve the spool output. I can actually just very quickly have a look in here, and I have access to everything from the JES message log to the system out of my application saying, I've opened an account for you, which is considerably easier when I'm trying to debug a test. I'm not having to log on to multiple systems to find the differing views between where were my 3270 screen recordings going. So here we can see them, which is all very nice. And also where the screenshots from the Selenium drive are going. So here I mentioned the fact that we were running Firefox inside of a Docker container, which I think again is really cool. And I could even see the screenshots that the application took. We can see that we entered that account number, we can see we can enter that amount, and we hit submit, and we actually had, you've completed a successfully, completed the transaction successfully message, returned straight to the browser. So I have all the tools that I require to go ahead and start debugging a problem when we do encounter test failures. So that is a kind of very simplistic view. And obviously we've just run this test locally on my laptop. This isn't the whole story. So I'm going to pass you back to Will, who's going to take you through what might be actually how you'd expect to start running Galasa tests.
Thanks, James. So yeah, so James quite neatly showed a single Galasa test that could interact with multiple endpoints. So just to enumerate them, we had a Docker container, we had a web UI, we had 3270 terminal interactions, and we had some batch jobs. Now that was 4 elements in, quite a basic test. But you could have quite easily seen about how we might want to include MQ in there, how we might want to include some file IO in there. And that's not the only combination. Just, we decided to go through that combination, but you can use the managers in any order. And the output from that test, the bits that James stepped through, such as the screenshots, the 3270 screen recording, the automated pulling of batch jobs and listing them, That's great for problem diagnosis, but it's also great for auditability. If you want to prove that this test actually ran, it's useful to have all of the artifacts listed to say, well, we interacted with the web page, we got this response. We then ran this batch job and we got this output. So you can prove that the test did exactly what it needs to do. Now that test that James performed there was really just in the proof of concept stage of Galasa, in that he installed the Galasa plugin into Eclipse and he'd used the Galasa framework to write his test and to run it locally. So all of the configuration that test needed was local to James's laptop. And he can quite easily, quite quickly go in and just change a line of code, hit play, and rerun the test. Or he can set breakpoints in the test and debug it line by line. And that's particularly nice if you've got a test that's failing, to be able to run it up to a certain point, stop it, and then go and log on to Kix yourself and see what's happened, see why the test isn't working as you think it should. Each time he runs a test, in the background, within Eclipse, we spin up a new JVM. And that test lives inside that JVM. So we have an element of control. When the test is finished, we completely trash that JVM. So it means that two tests can't interact with each other. And that's great while you're proving that Galasa has the capabilities that you need, and while you're a lone developer or a lone evaluator of the technology. But you're going to get to a point where more than one person is going to be trying to write a Galasa test. And excuse me, at that point, it would make sense to be able to share some of the configuration between users. So we have the Galasa ecosystem, which provides those types of capabilities. And for a local test, the test can still be run locally on your laptop, but now the output of that test is being stored on the Galasa ecosystem. And the configuration for that test is being pulled from the ecosystem. So although the test is still running locally, you're now sharing configuration information with other testers, and also you're sharing the results of those tests. So other people can see what tests have been run and can help debug if there are problems. But that ecosystem can do more than just run a local test. That ecosystem can actually run the test on your behalf. Obviously, you don't want to be running tests locally constantly. It's great while you're developing a test, so you just want to have a quick check or something. But if you've got a whole set of tests you want to run, you don't want to be timed up your local machine writing or running those tests. So the ecosystem gives you a way to run the tests completely headlessly. So it doesn't need to bring up any 3270 shell programs. It doesn't need to have any kind of UI. It's just 100% headless automation. And you can give it a whole set of tests to run. It can go away and it can run those tests and just let you know when those tests are done. Of course, once you've got to that point where you now have a set of tests running in full automation, there's another actor that's very, very important. And that's going to be the CI/CD pipeline, because it's not always going to be a human that's running this suite of tests. It's going to be your pipeline. Now, we've already got the architecture to run those tests in full automation. We just need a way of calling it. So we started off with a very simple REST endpoint that you could just make a HTTP REST call to and get back and say, run these tests, and then how are my tests doing? It's like a child when you're taking them out somewhere nice, you know, the little kid in the back going, are we done yet? Are we there yet? It's like the same thing with the test. Have my tests run yet? But we migrated away from that REST endpoint because although it's still there, you can still use it. We now provide a CLI, so it allows you to bring your own pipeline to a Galasa install and use any pipeline to run a set of Galasa tests. So let's have a look at that ecosystem in a little bit more detail. Like I said, the ecosystem is a central point of control to provide you with sharing of configuration, results, and allowing you to automate or execute automated tests in a completely headless environment at scale. And if we think of it, it's just a set of cloud-native microservices that control the Galasa runtime. So it sits, if you think of it as a black box, you can connect your Eclipse IDE up to it, and you can use that to submit tests. Go run this set of tests. Can you show me the tests that have run, and can I have a look at the results that those tests produced, please? So that's one use. But it also provides the capability for a pipeline to come in and ask the same questions. Can you submit me a set of tests? Can I get a JUnit report, a style report for those tests, please? So it is providing you with that enterprise capability to run these tests in parallel. And I know I keep going on about parallel, but that is really one of the key differentiators of Galasa. A lot of test automation frameworks will just run tests sequentially because it's the safest way of doing it. Actually running them in parallel is a much harder, and it requires you to do an element of resource managing. And that's what the Galasa ecosystem does. That's why we need it, because we need to control the access to those shared resources. So let's have a look at some of the capabilities of that ecosystem in a bit more depth. So like I said, it's got a full view of the entire configuration that your tests are using, and that's shared amongst all your testers. Everyone's using the same configuration. They're not taking a local copy of it. They're always going back to that central source version of the truth to know what the configuration should look like. It also provides a level of resource management. So this means that if something gets provisioned or a test is using a resource and that test dies, then the Galasa ecosystem can understand that that test has died for whatever reason and restore that shared resource back to a known good state. That may just be cleaning something up and deleting something. That may be running a sequence of commands to reset it, but it is protecting and managing those shared resources constantly as tests run. It's also storing all of our test logs, now all of our test artifacts in a central location. So anyone can inquire of the ecosystem and say, hey, we ran a test at 3 a.m. last night. What did that test show? What artifacts have we got back from that test? We can run tests in parallel. Even if a certain ZOS image or endpoint can't run tests in parallel because of the types of testing that you're doing on there, Galasa can handle that and can queue tests up. So even if a large set of tests come in, and for whatever reason we have to single thread onto a single ZOS image because of the nature of the tests, Galasa can manage that that pipeline of tests and run tests in parallel where it can, but also single thread them where it's necessary. It provides CI integration for any CI or CD product. So it's very much bring your own pipeline. We started off with a Jenkins plugin and we'll shortly be retiring that as we move towards this CLI that allows you to, from any pipeline, run a set of tests and wait for those tests to run. So this means if you're using Azure pipelines, if you're using Jenkins, if you're using whatever, you can connect to the Galasa ecosystem. It provides cataloging of tests. Cataloging of tests is a really important concept, because if you're going to say, run me my tests, well, what tests? You don't want to have to keep a text file of all the tests that you can run, because that file is going to get out of date. So instead, we dynamically build a catalog of tests from the test data itself. And we provide that as part of the ecosystem. So you can just say, build me a portfolio test that tests this particular aspect of my application and get a up-to-the-minute view of the latest tests that are ready to run. And when we run a test, each of those tests is run inside its own Docker pod. So that means it's completely isolated from the rest of the environment. It can't see another test that is running. It can only interact with the ecosystem and the Galasa framework through our APIs, which means it's completely isolated from things it shouldn't touch. So we know we can run the test robustly and reliably in parallel. And all of these aspects combined give us what we call testing as a service. It is an endpoint where you say, go run me some tests, go find me the information about this test. What configurations do I have available? And this endpoint provides it back to you, rather than it having to be installed on a node in a pipeline, and then you start getting issues with parallel running. Providing it as a service and provisioning it as a service means that everyone in the enterprise can make use of this testing capability against your ZOS or hybrid cloud applications. And that would be great. That's good enough. But if the managers that we spoke about give you an understanding to a particular capability or a particular technology or a particular integration point, wouldn't it be great if your infrastructure or your application was just another one of those integration points? What if you could have objects within your test code that natively understood your application or your infrastructure. What benefits could that provide? Let's have a look at that in some more detail. So we already spoke about the concept of a manager being an extensibility point that allows Galasa to interact with a certain technology or platform or tool. Now, these managers will provision an object into the test, and James showed that in his earlier demo. And they also provide an API within that object to allow the tester to interact with that object in a really easy, simplistic style. Now, by doing this, we abstract away a lot of the complexity of binding to a particular tool or technology, finding out which is the right endpoint for us to use for this particular run of this test. And we also abstract all the things around understanding how to pull back logs for or artifacts, or what artifacts we should log for this particular technology. So, for example, I'm working on a queuing manager at the moment, and I've got an attribute on the declaration of the queue that says queue that says I want you to log all of the messages that we put onto or take off of this queue. And that's it. It's a Boolean. Once you set that Boolean, we handle everything else. We handle the message type, we handle the logging, we handle if it should be put locally or in the ecosystem. It's completely abstracted away. Could we provide this same capability that a manager provides for a test tool to your infrastructure or your application? And the answer is, yeah, we can. We do this in a way with Kix. So we provide a set of Kix managers to allow you to interact with CEDA or Keki or CEMT or Kix. Now, these are managers that we use internally because we're forever, disabling or discarding a resource, installing a new resource, testing that resource, and doing those types of things. So these are managers that we've used internally that we're now contributing to the project as being really useful. So using these managers, I can now think about creating a manager for my own infrastructure. And we've got customers that have done, can we just go back a slide? Sorry, James. That have done exactly this. We've got customers who have written, using the Kix managers, a set of infrastructure tests. And they've abstracted that set of infrastructure tests into a manager. So now, before any test runs, their manager gets invoked and it goes off and it checks are the kind of key resources that I need for this Kix region up, available, and enabled. Are they ready to go? Is this Kix region good? So a good example is checking that my JVM server is installed and enabled. And it does that before it does anything else in the test. I've completely lost my train of thought. So we're going to go on to the next slide and hopefully that will re-jog my memory. So we've got those Kix managers, but that's just a set of the managers that we are providing through the Galasa project. So on our website, galasa.dev, we list all of the managers, and there's support for ZOS technology, support for middleware products, support for different test tools, and the managers all work together. So if you were thinking of writing your own manager to understand your infrastructure or understand your application, you can rely on those other managers to provide you with the capabilities that you may need. So this means that if I'm writing a manager to understand my infrastructure, I don't need to go on to work out how do I interact with Kix. I'll just use the Kix manager to do it. If I need to run a batch job to check that a file is loaded correctly, I can use the batch manager to do that piece of work. I don't need to reinvent the wheel each time. And then my manager can provide services to my testers to allow them to drive my manager to check for things without them having to do all that work themselves. So this leads on to talking about application managers. An application manager shares the same life cycle as any of the other Galasa managers. There's no differentiation in terms of level of support. So an application manager can only do certain things, but one of our managers can do a better set of things. They all exist within the same framework life cycle. And the capabilities of an application manager allow you to provide certain sets of boilerplate code to your test classes that otherwise you'd have to have, just cut, copied, and replaced each time you needed to make a change. So examples, maybe logging on and interacting with a session manager if you're going to do some 3270 interaction. Maybe understanding how to deploy data into your application and using the batch manager or the command manager or the file manager to provision some of that data. So the application manager really allows you to do all the same things that a normal manager provides to a test, such as abstraction, removal of complexity and cleanup, but allows you to apply that to your application. And for our second demo, James is going to absolutely show how that can be done. So we're going to take the same application that we showed you before, the same test, but now we're going to augment it with an application level manager alongside the other managers to reduce some of that boilerplate code that was in the test to make writing a new test even easier to do. James.
Thank you very much. Yeah, I'm back again, and this is where the demo section gets a little bit interesting for myself because I'm actually going to be doing some code changes and rebuilds. So if something's going to go wrong, here is the section it's going to happen. So yes, we're looking at the same application, and one of the things that I potentially didn't discuss earlier is the Kix application actually has a batch interface that allows me to open new accounts. And if we skirt back across to my test and actually have a look at it again in a little bit more detail, I have a set of what we'll discuss as boilerplate methods to allow me to do certain things like provision accounts. This is particularly important in our parallel world of testing because what happens if I've got multiple tests running against this same application? We want each one to come along and be interacting with a slightly different piece of data so we don't have any collisions. So one of the things that I did in this test is I wrote a bit of boilerplate code, which I might start copying around and pasting into lots of different tests that goes away. It checks the existence of account to make sure it doesn't exist. It goes and provisions that account using that batch interface by submitting the batch job. It then drives 3270 screens again to ensure the fact that that account has been opened and it's got the balance that we expect it, and then passes it on to the three tests that we saw earlier. So it's a section of boilerplate code, which, as I say, I might end up copying and pasting amongst lots of tests. So what I'm going to do now is I'm going to prove you don't need it, and I'm going to comment it out, which should hopefully show some errors coming into my code. So if we go and have a look here, that provision account boilerplate method that I had is now throwing an error saying I don't exist because I've just commented it out. So what I'm going to do instead is I'm going to utilize an application manager, which I designed in Blue Peter style of here's one I've got earlier, which, if I just minimize that quickly, is called the Galasa Demo Data Provision Manager. I'm not going to jump into it because like the whole lifecycle message is rather large, but it's not a particularly complex bit of code. It's only 6 classes, which most of them are interfaces anyway. But it allows a location for my boilerplate code to sit and allow a tester to interact with it without having to worry about having it inside of their test class each time. So how do I go about implementing it? Well, at the bottom here, I snuck in a couple of super secret annotations, which I'm now going to paste back at the top. They don't have to be at the top, but it's nice and pretty to see all of my managers in the same location. And I'm just one of those coders that likes things to be in set orders. So I've asked here for a data annotation and an account 1 and account 2, because I want to be interacting with 2 different accounts in this test. And the Galasa framework is going to see these new annotations, and it's going to use my new data provisioning manager to go and do the same work that my piece of boilerplate was doing. So I'm going to comment out the methods here and comment in the very conveniently placed methods saying use my account 1 and just provide me the account number. So I've not had to go away and provision it. I've just asked the Galasa framework, you've made an account for me, right? Perfect. What's the account number? So there's one test corrected. Let's just go and quickly do the other one because it's just the same bit of code again where I conveniently place some commented out code. We're going to hit save on that, and we're going to very quickly rebuild it. So let's come to my Symbank tests and just go run those, maybe install. And hopefully the console will come out, and that should pass first time, hopefully, because I didn't make any serious code changes. And yay, build success. So I'm just going to do what I did last time, and I'm just going to run our test again, which doesn't take very long, but we will we'll let it fly by and do its thing in the console. And remember, this test is bringing up an entire environment. It's provisioning a Docker container which contains my cloud-hosted web server, which I didn't discuss earlier, but is actually another set of application managers which understand my SymBank application. So I have two application managers in this test now. I have an application manager that understands how to deal with my data for my application. And then I have a manager which is understanding my application itself, where the SymBank terminal is an object that knows how to log on to the correct ZOS LPAR, which my application is installed. It knows how to log on to Kix. It knows how to get to the system's main menu. And oh no, we actually hit a failure in my test. Yay, I did tell you guys that this was the moment that it was all going to break. So we failed to start a new session. Oh no. That looks like a Selenium problem, which I wasn't actually anticipating because we didn't make any changes to the Selenium. So what's it said?
I think this could just be that your laptop is under an awful lot of stress at the moment and wasn't bringing things up in a good amount of time.
So I can confirm that. Yeah, that is probably the case. So I'm not going to bother rerunning it. It is actually the container on my laptop is struggling so much because I'm doing so many different things at the same time that it did time out. I could have increased the timeout, but I'm not going to bother right now. So unfortunately, I won't be able to show you that bit, but I will be able to show you certain components. So I'm just going to quickly load up the results again, because this is one of those moments where something did actually go wrong. So we want to see what went wrong, and we can see from our results here that it was actually the web app integration test that failed. So hopefully, when I come across to my stored artifacts tab now, we actually have a new tab here called provisioning. And these are the provision bits of JCL that was submitted to actually go away and open up an account. So we asked an account to be open, and we passed it a account number, a sort code, and an opening balance, and that job was submitted. But I have access to these resources, even though they were run outside of the test now. This was run as part of the manager lifecycle, and I can still access the spool output, which is here. So I can see that one of those accounts was 22485218, and I still have access to the entire spool output for that job. I didn't lose any information from a tester's perspective to incorporate a data provision manager, but I had a huge gain, because what happens if something changes? Let's say the batch interface for opening this account is just changed, so we have to make some changes to the piece of JCL that's submitted. I don't have to go through my very optimistically numbered of 10,000 tests that are interacting with this interface and make a change to each one of them. I could just come along and make a change to my manager in one place, and the implementation of how we're interacting and creating this data is rippled across my entire test corpus. I don't have to make any changes to the test code itself, which just makes life a lot easier when we do come across updates to our application in our code. So unfortunately, as I say, that failed, and we could dig into the run log and have a look what actually went wrong. But instead, because we're running out of time now, I am going to pass you back to Will, because I do want to leave some time for questions at the end.
Oh, thank you, James. And if nothing else, we've learned that we should make more sacrifices to the demo gods previous to running a live session.
Yeah.
But these things happen. And what is actually good to show there is, even though the test failed, it was just that one method that failed when we tried to bring up the web application. Other parts of the test succeeded and were fine, and we still got all the logs and all of the artifacts. So you could actually drill in and see exactly what the problem was. But know that even though we had that failure, Galasa still did all of the cleanup activities that it needed to around that test. So it means that the next test that runs in that environment has as good a chance to run as any of them, rather than a failing test leaving some state behind, which then trips up one of the subsequent tests. So the point of showing you about the application manager was really how you can start to elevate a your testing logic or your testing architecture to not just understand the tools and the technologies and the platforms that your test needs to run on, but also the application that you are testing. Now, obviously, we can't provide you with those managers because we don't know your application, but we can work with you to write managers to understand what your application does and provide capabilities to your tests. So we want to have a chat about some of the ways we've seen Galasa being used, not just by us internally, but by our customers, you guys. So we've seen people use Galasa for doing things like infrastructure basic verification tests. So here's just some examples of some tests that we've written that do a similar type of thing. So the first one, we want to check the status of a JVM. So I am calling out to the CEMT manager to inquire on a particular resource. In this case, a JVM server called DFHWLP, one of the standard name JVM servers. And it produces me a hash map of results. And then I can say, well, now get me the enabled status of that. And it returns back and goes, yeah, it was enabled. Great. And we can assert that that is the case, that JVM server is enabled. And there, if you take away the logging statements, you've got 3 lines of code checking the status of a JVM server. You don't have to worry about 3270. You don't have to worry about the connection or where the KIX region is, or have I turned COT TRAN ID on? Just 3 lines of code, let the framework take care of the rest. In the second case, we're trying to find the status of a program resource and check that that's also enabled. Again, 3 lines of code. Another one, which I think it's just the same thing, which is checking the enable status of a library. So going on to a KIX region, is my JVM server there? Is my program there? Is the library there? And are they all enabled? So these are tests that can be done inside an application manager or as part of a infrastructure test to validate that my infrastructure is good and sound before I run all the other tests. So checking that the KIX resources are there. We've also seen people drive 3270 logic purely just to replicate a set of functional tests that they already do manually on their system. So just interacting with the 3270 terminal and doing a basic set of functionality tests, which now they've got automated and they can reuse as part of a wider testing initiative. We've also seen people use the KIX managers to link to a KIX program. So for non-terminal started transactions, just be able to start a KIX program with some data and say, right, this is the data I'm going to give it. This is the data I should get back. Can you just assert that that's the case? And they've written Galasa tests to do all of these types of things. Next slide, please. One of the most exciting, if you've heard us speak about Galasa before, this is one of the things we are most excited about, is that all of the Galasa project, everything that we've shown you so far today, from the framework to the ecosystem to the CLI, is all being delivered as an open source project. It's all on GitHub. All of our builds of the product are available through Maven Central. And you can access all the information about Galasa from galasa.dev. Doing this in open source means that because we are giving you all of the implementation details, you can take Galasa and you can change it to do whatever you want. And we've already got customers that are starting to pursue this. We've got a customer who have been looking at writing an application manager to understand their application, but they need some finessing around how we handle 3270 data because of their application, because of the way their application produces a 3270 data stream. So we're going to work with them and they're going to be adding code into our 3270 manager to allow them to have that capability. So they'll be contributing code back to the Galasa code base as a community for us all to use. And this is really quite powerful. So all of it's available in open source. We've been making regular contributions and releases into the open source train, and it's all available on galasa.dev. But one thing we did do earlier this year that I want to just quickly touch upon is Galasa was taken, because it's all released under a Eclipse public license version 2. IBM actually took the Galasa project and created a redistributable form of Galasa called the IBM distribution for Galasa. And that's available as part of the VTP offering. Now, I'm not going to talk any more about it because I understand it's GSE and I understand the rules, but just to say that Galasa as an open framework is available, but it's also becoming available as a redistributable product from other vendors. So if you're not too familiar or happy with accessing open source code or open source artifacts yourself from within your network, then there are distributions of Galasa available to allow you to do that without having to handle all of the open source stuff yourself. Next slide, please, James. So, bringing back, making what was the title of this session? Galasa Half Full, bringing optimism back to integration testing. And we started off by saying that integration testing was hard, and I'm going to still stand by that. Writing automated integration tests is not a straightforward thing. But because Galasa is open source and I can easily access it without having to do a POT or pay for anything or do a proper trial, I can just download the code and play with it. Because it has interconnectivity with ZOS, the cloud, different bits of test tooling, meaning that I can integrate with my ZOS LPARs, meaning I can run batch jobs without having to install anything on ZOS. Being able to write my own application managers to be able to understand my application, and so I can just use one line of code to do a whole slew of things against my application. And having the Galasa ecosystem that allows me to run my tests in automation at enterprise scale and link it to my CI/CD pipeline, well, that's just taken a lot of my worries away. And that gives me an awful lot of optimism. So using Galasa to automate my integration tests, that's a lot easier. If we've interested you at all, and I hope we have, then this slide is perhaps the most important, because everything that we've said, all the code that we've gone through and we've played with today is available on these communication mechanisms. We've got our external Slack channel, which is free to join at galasa.slack.com. You will need to get an invite, which is an automated process. You can go to galasa.dev to get that invite. And while you're looking at that, to get that invite, you can be looking at all of our introductory content, all of our documentation, and read about how to get going with the Galasa project. We also include a little demo application called SimBank that allows you to bring up an ZOS style application on your laptop and a set of tests that you can execute without going anywhere near your mainframe to get an idea of what Galasa can do. And finally, we've got our GitHub repos, all under the organization of Galasa-dev, where you'll see all of our code and all of the project management where you can raise issues, see where the project's going and seeing what we're working on at the moment. 7 minutes left. That was quite quick, James.
It was, but it's given hopefully some time for some people, which I can see some questions have come into the chat. Two from Anthony, which is, are there any IMS managers available? Which there isn't currently, no, but I believe there has been some discussion in this area. Will, do you know a little bit more about
that? Yes, so it would really depend on what you want to do with IMS. If you just want to log on to IMS, you should be able to use a 3270 terminal to do that. If you would like an IMS manager, please tell us what you would like that IMS manager to do. We're happy to have those conversations, work with you. Because we're an open project, we can develop and we can have those discussions quite nicely and quite openly, and we can understand what your requirements are and what the best ways to work with that are. We are also working with the IMS team within IBM to look at how we could provide an IMS manager into the open source project.
And this is one of those advantages of the fact that we do all of our project management out in the GitHub repositories, which were on screen a second ago, because you can just come along and open a quick issue, whether it's just even a question of where is this manager, and it's kind of, are we looking to do this soon? Because it highlights to us, the development team, what the community is looking for at the minute, and allows us to plan these pieces of work to see that people are interested in the fact that they want something like an IMS manager.
The second question in there, how quickly can you pull up, tear down mainframe environments, for example, the established known state for a Kix environment between tests? So this is quite an interesting question, because we won't provision ourselves Kix regions, because that's really should be part of your CI/CD pipeline. But what we do have the capability of doing is providing the test with capability to interact with that. So for example, we have customers who are producing Z development and test virtualized LPARs as a output of their CI/CD pipeline, and they want to run their tests against that virtualized environment, especially at the early stages of integration testing. So to do that, we can choose between a ZOSMF or RSE API, whatever's installed on that ZD&T image, without changing the test code. So we can bind to that ZD&T completely transparently. In terms of a real ZOS environment, switching between ZOS environments is of no real performance implication whatsoever. Because we don't provision and don't deprovision anything, it would really depend on what the provisioning stage of your application was. We don't do that from a test perspective because it's not really our role. It should be another part of the CI/CD pipeline, a deploy phase that does that.
Yeah. This isn't to say that you couldn't have some pieces of work put into an application manager which do things that make sense for a test. Obviously, I'm not suggesting that you should be using this to do everything. But if there was a piece of work that was required to bring up and down an environment that you're expecting for a test case, creating an application manager like the one I showed for the data provisioning, but for something that understands how to work with environments instead. It would depend on the processes you took, but it would be definitely capable to have that from a tester's perspective. Is there any more questions?
I don't think so, chaps. It's very interesting to me. I mean, probably a little bit of a question. So I'm going to be upgrading kicks next year when we take Vulcan. And let's just say I wanted to use Galasa to do some of the testing of all our applications and things like that. Who do you think should be running with this? Should it be the kicks team, or should it be the test team? Who's got the right skill sets in your experience to pick this up, run with it, and admin it? Because I don't really want it as a one-off like testing the kicks release. We want it to be there going forwards.
It's a really good point. We've seen both. We originally focused this at application developers, the application test teams, because it's a test tool, and if you want to pick a persona, then pick a persona with test in it, because then you've got a natural lexical link between the product and the role. However, some of our success has also been with the kind of systems programmer infrastructure community. So we had one customer who would upgrade an environment or provide maintenance APARs onto an environment. And in doing so, they would then have a set of tests that they wanted to run from a kind of system perspective on their environment to prove that everything was up and that nothing had fallen over before they handed the environment back to the applications team. And so they took Galasa and they wrote a set of tests that they can run post a maintenance window to prove that the system is up. So when the application team come in the next day and their COBOL attempts to do a division by 0, then the systems guy can say, no, the application is actually up. The systems are up. It's your code that's caused the problem. Now, where that goes from there is you then start to see people go, well, we've got this set of tests that prove that all of the resources in kicks, for example, are up. Well, how about we just do a basic test of the application? What's the most simple thing we can do with the application? At each of these points, you're showing a little bit of value. It's one less thing that, Rob, you have to do each and every time. You now click a button and it's done for you. And so you then start to see that like window of opportunity grow. Well, we've got a tester that tests all of our ZOS resources. How about we now test what happens if we call one of the APIs? What happens if we now drive one of our legacy or older interfaces to see if that's still working? And you start to see the kind of the amount of tests start to grow from that perspective.
Okay. Thanks, guys. If there's no more questions, I'm going to thank you very much both for your efforts. This is session 4AZ, folks. So if you can fill in the feedback form, that would be great. There are prizes. And I'll be seeing everyone tomorrow at 9 a.m. And I can't remember what the presentation is.
It's the Steve Foley one.
Oh, it's Steve. Yeah. Yeah. Okay. It's more kind of testing stuff, but without Kix regions. So that'll be very interesting. Okay. Thanks, Nick. And thank you, Will and James.
Cheers, guys. Thanks,
Appreciate it, guys. See you all soon.
Bye-bye.
Cheers, everyone.